Yeah, hi everyone. Okay, so today we're gonna
Next, we go with EMF or electromotive force. In EMF, basically, just imagine that you have a waterfall. Waterfall, normally the water comes through the high steep peak towards the lower bottom, and from lower couldn't go toward the upwards. So the process is only one type of process, from higher part to the lower part. So it means that the flow only occur in one way, for example in the waterfall. Alright, so same goes to the electrode. So basically, electrode can only flow from high potential energy towards the low potential energy. So high potential energy, so normally that's occur in anode, and then the lower energy normally known as the cathode. Alright, so the potential difference between the anode and the cathode itself, we call it as electromotive force or EMF. This is also called a cell potential, where it designated as E cell or cell. Okay, cell potential normally we measure in volt. The unit is in volt. 1 volt is equivalent to 1 joule of work or 1 coulomb of charge. So 1 mole of electron, as we know, is equal to 96,500 coulomb of charge. Okay, so we can say that 1 volt is equal to 1 joule over the coulomb. Right. Okay, so next, cell potential is a competition that is actually happen between two half cell. Which one have the higher potential, which one got the lower potential. Alright, so every half cell have tendency to gain electron and proceeds as a reduction half reaction. So we can say that between the electrolyte or voltaic cell, one should be undergo reduction, another one would be undergo oxidation based on their potential. And that's why the name of electrical potential is based on reduction. Based on this reduction potential, if it's only reduction potential, we call it as E. Okay, but this is relatively easy to gain electron. But if we talk about standard reduction potential or E node, so normally node is noted for standard, so that is reduction potential measure under standard condition. So you know standard condition is where you have temperature or you have concentration that is fixed at that time. Okay, this is a standard reduction potential table that I told you in the lab before. You have seen this. Okay, so we have a potential base or reduction occur on the half reaction. It doesn't matter what actually it is, but it based on the reduction itself. So meaning that all the element here of substances here are gaining electron, because reduction is gain electron. So based on that, we just only this table is only refer on reduction or gaining of the electron. So let's say if your half cell occur on oxidation, so you have to reverse the equation, and also the potential. Okay, so the potential basically the more positive is seated on the above, negative is seated on the bottom. Okay, alright, table just now. So this is the hydrogen with the red one. Okay, hydrogen here. So meanings, whatever, okay, if you have two substances, you have to hydrogen as the landmark here. Okay, so you have to look at between these substances. For example, we have fluorine and lithium. Between these two, you have to look at to the table who is seated on the top of the table or who is seated bottom on the table. Okay, so let's say from the table we found out that fluorine is on the top of the table, which is process is more reduction happen here. Okay, and then lithium is seated on the below, so means that this is more oxidation will be happen here. So if you are oxygen, you are better reducing agent, so this is the strongest reducing agent. If you undergo process of reduction, you are the strongest oxidizing agent. Okay, right. And copper just now, so we know copper is reduction and not zinc is anode. Zinc is oxidation, yeah, zinc. Okay, so we put zinc towards zinc to plus, because this is lower oxidation state, which is oxidation state is 0. and zinc 2 plus, oxidation state is 2 plus. Okay, copper on the right. Okay, this is what happened in cathode. Our cathode is copper. With the higher oxidation number is copper 2 plus, lower oxidation number is copper, which is 0. Oxidation number is 0. Okay, 2 plus to 0. Okay, so when you write the equation, you're gonna have half equation like this: zinc towards zinc 2 plus, lost 2 electron, process of oxidation, and then copper gain 2 electron, process of reduction. Okay, and to produce the copper. Okay, all right. So another example, you can also write, this is known as the cell notation. This is complete cell notation macam ni. Alright, another one, if you got any extra inert electrode, for example in this case we got graphite, so you can put graphite at the beginning and at the end of each electrode. This is the case that graphite has been used for both electrolytes. But if the graphite only being used at the anode, so we just put at the anode. There's no need to write at the back. Okay, so there are another example of electrodes that can be used as reference electrodes. This is known as electrode reference. Okay, another than graphite, we can use as platinum, okay, platinum, and also palladium. Okay, can also be used as the reference electrodes. Or the most easiest, the most simple is carbon. Carbon also can be used as this reference electrode. Okay. Okay, this is inert electrode, which means that it's not involved in the reaction. It just treated as a reference. Okay, alright. So that shows you where to put the electrode of reference in the beginning or at the end, depend on the electrode itself. We refer on hydrogen. Don't have to worry about that. So we go with standard cell potential or E node. E node. Okay, we just learned just now how to calculate the potential or the higher potential versus the lower potential. Remember the waterfall just now. Okay, so now the formula is actually E naught cell is equal to E naught cathode minus E naught anode. Okay, so what is our cathode value? Okay. The charge always been put it in. Okay, this is compulsory. Alright, and also the units. That is compulsory. You can look at zinc and copper. Okay, again, if you use the formula of change anything, so the value is remain as well as a positive 0.34. Now only you can apply formula. Oxidation plus reduction. Oxidation is positive 0.34 plus with 0.76 of the zinc just now that has been reversed, the sign also become positive. Kan? Alright, so the value now similar as before, positive 110 volt. Okay, this is where you have to be. Right, so next is to do this example. Write the notation cell for voltaic cell consists of one cell of chromium in chromium nitrate, another half with argentum in argentum nitrate using salt bridge of potassium nitrate. So I want you to do this, okay, as your exercise, and we continue with the third part of the video. Okay.